Hello, math students. Welcome back to our module on percents and proportional relationships. This is lesson 7, and it is called Percent Increase and Decrease. The goal for today's lesson is, today we will learn how to solve percent problems with percent increase or decrease. The question that I want you to be thinking about in this lesson is, what amount does 100% always represent? Okay, so there's a couple of things that we need to learn about and remember. They're called the things to know section, and they are, when an amount changes, it can be called a percent increase or a percent decrease. So if you start out with a specific amount of something, let's say cookies. So let's say there were 12 cookies in the cookie jar, and then Mrs. Nelson ate 4 of them. Did the amount change? The answer is yes. So what happened is the total was 12. She ate 4 of them, so the new total is 8. And so basically what your job would be is to figure out what is the percent decrease of the cookies. Because there were 12, she ate 4, so now the new total is 8. So your job is to figure out the percent decrease. Okay? If the amount changes and you end up with more, then it's called a percent increase. The way to determine the change is by comparing the old amount to the new amount. The old is considered the original amount, 100%. The new is the change that happened. Okay, so the new percent is the change that happened. Basically, what you do to figure this one out is you use quantity equals percent times whole formula, and then you find the difference between the old and the new, and then you use that formula, okay? So some new information that we're figuring out as far as percent increase, percent decrease, is you have to establish what was your original whole, how it changed, it either subtracted or it added, and then you're figuring out the new percent of the change, okay? Find the difference between the new and the old, and then use the formula. Okay, so that's pretty simple. Basically, what you're doing with that one is you are finding the difference means that you're supposed to subtract. So you're going to take the new minus the old, and then you're going to divide it by the old. That's how we figure it out. So you take new minus the old, and then you're going to divide by the old. That's how we work it out to figure out that formula that they're talking about, okay? All right, so let's practice one of these and see what happens. An item was selling for $72. An item was selling for $72. It is reduced to $60, so a change took place. So the original, or the old, was $72. The new price is $60, so it was reduced by a certain amount. Find the percent decrease and then round to the nearest tenth. Okay, so basically what you're trying to figure out is we can use the quantity equals percent of whole formula, or we can use the new formula that I showed you right here. And so to do that, we remember that 72 was the old and 60 is the new. And then to use the quantity equals percent of whole formula, then we would say that 60 equals what percent times 72, because that's what you're trying to figure out, right? And so we're looking for the percent. The percent is the missing information. So we're looking for the percent, okay? And so what you would do is it says that you find the difference between the new and the old and then use the formula. Well, it was 72, then it was reduced to 60. Find the percent decrease and round to the nearest hundred. So the new amount was 60, right, minus the old amount, which was 72, and then we divide it by 72, and that will give us our percent decrease. And this right here, obviously, is going to end up with a negative value in the difference, right? Because 60 minus 72, you have 60 positives and 72 negatives. And so when you are left, you have negative 12, right? and then you have divided by the old, which is 72. So now I have to take negative 12 divided by 72, right? And so I know that 72 can't go into 12 evenly, so I'm going to make it a decimal. And I know that 72 can't go here, so that's a 0. 72 goes into 120. Let's say maybe, well, I don't think it can even go twice, because twice would be 144, which is too much. So one time. So 120 minus 72 gives us 48, and then we bring down another 0. How many times can 72 go into 480? We'll try 6. 6 times 2 is 12. 6 times 7 is 42, 43. Then we subtract that, and we get 48 again. So now it's just going to repeat, right? And it says round to the nearest tenth. So if this is hundredths, this is tenths, so that would be 0.2 rounded to the nearest tenth. And then we have to times it by 100 to turn it into a percent. So we get 100 times 0.2, and we get 0, 0, 2, one decimal place. So that would be 20%. So this percent right here is 20%. So it would be a 20% decrease. Okay? So that is how you use that new information to help you figure out. So you take the new minus the old, and then you divide it by the old, and then you times it by 100, and that gives you the percent of difference between the two. And this one is called a percent decrease, okay, because the original dropped 12 to get to 60, which is a 20% decrease, okay? All right, kiddos, that's all I have for you in this lesson. Oh, wait, our goal today we will learn how to solve percent problems with percent increase or percent decrease, which is what we did. What amount does 100% always represent? 100% always represents your total. Okay? All right, kiddos, that's all I have for you. Talk to you soon. Bye.